like I was saying, we're going to be taking factors and multiplying them back together to get the polynomial equation. This is called formulating a polynomial. Now we did the same thing with quadratics actually. We did the exact same thing where they gave us the factors and said find the quadratic. Same exact process, just maybe a little bit more complex because it's a polynomial and you don't just have two roots, you have multiple roots. Now, they'll usually start by giving you the root first. Now, root, remember, root is another word for solution, x-intercept, zeros. It is x equals. So here in this first problem, they give us the roots of 2, 3, and negative 4. How do you take solutions and write the factors for those solutions? So remember when we're factoring, we factor, get our factors. How did you go from the factors to the solutions? Set them equal to 0. Okay, so now we have x is equal to a number. What do you think we do to get it back into factored form? Oh, I hate that terminology though. What are you really doing? You're bringing the constant over to be with the x, right? So technically you're flipping the sign, but not really. That's not really explaining what's happening here mathematically, right? We're moving these numbers across the equal sign to be back with the x. So I'm subtracting 2 over. I'm subtracting 3 over. And I'm adding 4 over. So these become x minus 2, x minus 3, and x plus 4. And then to create your factors, you just put parentheses around them. So we have parenthesis x minus 2, parenthesis x minus 3, and parenthesis x plus 4. Boom, we have our factors. Do you think you need to show this step 2? You don't need to show this step 2. If I was doing this on my own, I probably would look at these and go, okay, x minus 2, x minus 3, x plus 4. And that's exactly what they got there. Then, we now are being asked to combine these factors to create a polynomial equation. Who knows how we now recombine factors? Oh yes, you can read, good job. Foil and box method, yes. I like to call it double distribute, or just think of it as distributing. Now, can I distribute all of these all at once? No. What do you think you're going to have to do? Break it up. So I would combine the first two, multiply those together, and then multiply it times the last parenthesis. So let's go ahead and do that. Right here. You can do the box if you prefer the box. I'm not going to show the box because, you know, I don't really like it. I just think it's way more work, right? You got to draw the box. You got to put all the numbers in. I think I'm lazy, personally. I'm super lazy. So I just like to, draw swoops. Swoops are super easy. Boom, boom, boom. Can't follow the swoops. So, here, I'm going to combine, I'm going to multiply the first two parentheses. I have x times x, and what do I get? X times negative 3, what do I get? Then I'm going to distribute the negative 2 to x and negative 3. Negative 2 times x is, and negative 2 times negative 3. Good. Now, because I still have that last factor to multiply, I am still going to keep this in a set of parentheses and bring down the x plus 4 because I haven't multiplied it yet. What do you think I do here? Hold up before I distribute. I have like terms I can combine together. And I keep bringing down the x plus 4. So now I need to distribute everything here. I know that this really doesn't matter, but I like to distribute or think of distributing the smaller termed parenthesis to everything else. You can do it the other way. You can distribute the x squared to x and 4, distribute the negative 5x to x and 4, and distribute the 6x and 4. But that's a lot of sets, I guess, of distribution. When instead, I like to think of distributing the smaller term. That way, it's just less swoops. Not technically, less groups of swoops. I don't know. So here, I'm going to distribute the x to the x squared and get x cubed, the x to the negative 5x and get negative 5x squared, the x to the 6 and get 6x. Then I do the exact same thing, but for the second number in that parenthesis, 4. So 4 times x squared is 4x squared. 4 times negative 5x is negative 20x. And 4 times 6 is 24. Now what? Combine like terms. What are your like terms? The x squareds and the x's. So I end up with x cubed doesn't combine with anything. What do my x squareds combine to be? Minus x squared. What do the plain x's combine to be? Negative 14x. And then just the 24 combined with anything. So you're done. That's it. Making sure you have an f of x or a y in front to create the equation. Otherwise, it's just an expression. Now, this is in what form? What form is this polynomial now in? No. It's in standard form. This up here, this original in orange that I wrote, is factored form. Both of these are the equation. It's just they asked us to create the standard form of the polynomial. All right. So now, before I have you practice this, I do need to go over one more thing. Just one more thing. This is how to look at a graph. How to look at a graph and figure out your roots and then factors and then find the equation. So, the only trick is, when we have a polynomial, sometimes it'll do some weird things when it goes through the x-axis. And depending on how it goes through the x-axis, determines how many roots are actually at that point. So, if it just passes right through the x-axis, there's just one root there. There's just one solution. Do you see how right here, where it goes up to the x-axis and then bounces right off? What, if I was just looking at that part of this polynomial, what function does that look like? It looks like a quadratic. And how many roots does a quadratic have? 2. So, when your polynomial goes to the x-axis and then bounces right off, it actually has what is called a multiplicity of 2. This means that there are actually 2 roots there. So, if my root is x equals negative 3 at that point, x equals negative 3, what is the factor? X plus 3. Now it bounced off, creating a multiplicity of 2, so there are actually 2 here. So how do I write 2 of x plus 3? Squared. Exactly like they have written right here. This is when it goes to the x-axis and then bounces right off. You have to square the factor. Now, if I were to cover up the left-hand side of this graph and just look at the right-hand side, this last place where it passes through the x-axis, what function does this look like? A cubic, where it goes and then it kind of squiggles right at the x-axis there. It looks like a cubic function. Now, how many roots can a cubic function have? 3, right? It's cubic. 3. So, when the squiggle, the inflection point, happens right on the x-axis, it has a multiplicity of 3. Meaning, we take the root, which is, what is the root here? X equals 0. So what is our factor at that point? Just x. And because it squiggles, it looks like a cubic right there. It has a multiplicity of 3. What do I do to that x? Cube it. So let's see if you can't understand what was just said. Let's see here. Oh God. All right. Just go with it, okay? All right. So looking at this poorly drawn graph, it looks fabulous. What roots do we have here? Tell me my roots. X equals -3, x equals, and x equals 4. What are my factors for those 3 values? X plus 3, x plus 1, and x minus 4. Now, what is happening at those roots? So this first root, the line is just passing right through. Does it have any multiplicity? No, it's normal. We leave the x plus 3 alone. This second root, it's coming to the x-axis and then bouncing right off, looking like a quadratic. So what's the multiplicity there? 2. So what do I put in my equation? X plus 1 squared. Then this last one is coming to the x-axis and then squiggling, looking like a cubic. So the multiplicity is, so what do I put in my factored form equation? A cube. That's all. We will not ask you to write this polynomial in standard form. That's a lot of multiplying, way more than you would need to do. Why do I say this is a lot of multiplying? What do you actually have to do here? Yes, you have to write x plus 3 times x plus 1 times x plus 1 times x minus 4 times x minus 4 times x minus 4. That's a lot. That is a lot. Any questions on anything here? Also, just to clarify, I know we kind of alluded to it when I asked you how many roots does a quadratic have and then how many roots does a cubic have. Do you know what determines how many roots an equation could possibly have? If I tell you a quadratic has 2 possible roots. Now, why do I say possible? They could be what? Imaginary. So you have 2 possible roots, but they could be imaginary roots. Imaginary. X cubed, your cubic, could have how many possible roots? 3. Where am I getting this number from? Oh my gosh, the exponent. So how many roots could x to the 5th have? 5 possible roots. What about this? It is always determined by the leading term only. Whatever happens afterwards does not matter, right? Just like if you had a quadratic, I have this, and then say I added this on. Does that change the number of roots it's going to have? No. It still could have two possible roots, right? So here, how many possible roots would my x to the 52 minus x cubed have? Still just 52 possible roots. Does that make sense? All right. Over here on the examples, I want you guys to do 1, 3, 4, and 6. Now, number 1, if you don't want to deal with fractions, what can you do here? At the end, you could multiply by 3, yes, but so I have these roots. How do I then write my factors? What are my factors going to look like? Right here, at this step, what can I do right here to get rid of that fraction? What do we do when we're factoring and then we divide by a and it doesn't you kick it. You can do the same thing here. This becomes x plus 1, 3x minus 2, and x minus 4. Then we don't have fractions and we're all happy because I know you don't like fractions. Even though coming up next semester we have a whole unit on fractions. Rational functions. I love it. I am. All right, so go ahead and do 1, 3, 4, and 6.